Hello learners, welcome to this course on Embedded System Design using PIC16F877 Microcontroller. In this tutorial, I will be discussing about how to control the speed of a DC motor using PIC16F877 Microcontroller. So first let us start with the basics of a DC motor. So a DC motor is a direct current motor. So it translates electrical pulses into mechanical movement. So when I provide electrical signal to the motor, it converts it into a rotation, a mechanical movement. So if we see a basic construction of a DC motor, it has stator windings, so which is shown here as an electromagnet, and it also has a movable part which is rotor. So the rotor is an armature. When we give a current to the stator windings, a constant magnetic field will be produced by the stator windings. Same way, when I apply a current to the armature also will produce a magnetic field. So the magnetic field produced by the armature will try to distort the magnetic field of the stator windings. So thereby a torque will be induced and the rotor starts rotating. So here I have shown a simple DC motor. So we can connect a wheel to this shaft of the motor. So thereby it can be used in robotic rover applications and many other such applications. So if I want to change the direction of rotation, in that case, we need to change the polarity on the leads of the DC motor. So for example, here I have shown a motor connected to a battery. So positive terminal of the battery is connected to one of the lead and the negative terminal is connected to another lead. So let us assume that the motor is going to rotate in a clockwise direction. If I change the polarity of the battery, so negative terminal is connected to one end of the motor and the positive terminal is connected to the other end. So here you can see the connection is different. So the polarity of the battery changed. In that case, what happens? The motor starts rotating in anti-clockwise direction. So such type of motors are available in your CPU fan, which can be used for cooling your CPUs. So a DC motor, it moves continuously. So we can also vary the speed of the motor by three factors. By changing the load, I can change the speed. By changing the applied voltage and current, I can change the speed. So by changing the load, for example, if I increase the load, the speed of the motor will get reduced. If I reduce the load, the speed will be increased. Same way, by applying a voltage or current, by increasing a voltage or current, the speed can be increased. By reducing the voltage or current, the speed will be decreased. So the DC motor has two RPMs. One is no load RPM and a loaded RPM. So whenever we purchase a DC motor from a market, it states that it is a 100 RPM DC motor or 1000 RPM DC motor. This 100 RPM or 1000 RPM represents it's under no load condition. When we connect the load, automatically the speed of the DC motor will get reduced. So the current rating is nothing but the current consumption of the DC motor when a nominal voltage is applied with no load. Again, in order to get a particular RPM, how much current we have to give to a DC motor under no load condition. So that is nothing but the current rating. So a current rating can be from 25 milliamperes to few amperes of current. Same way, an increase in voltage from 1 to 150 volt will also result in the increase of RPM. So as the load is increased, the RPM is decreased. So I have said about three types. One is by varying the load, by varying the voltage, and by varying the current, we can increase or decrease the speed of a DC motor. There is another method by which the speed of a DC motor can be changed by using a pulse width modulated signal. So pulse width modulation is essentially a square wave where the on time of the pulse can be varied. If I have a wider pulse, then we will have a higher speed. So we will look at it with an example. So in the first plot I have shown the 50% duty cycle. So if I take a total time period which contains on and off periods, so out of this total time period, for the 50% of the time we have on, and remaining 50% of the time we have off pulse. So which means the amount of energy delivered to the motor is only 50%. In case of a 10% duty cycle, what happens? In the total time period, for only 10% of the time we have a on pulse, which means we are delivering only 10% of the energy to the motor. So thereby the speed will be reduced when compared to your 50% duty cycle. Same way for 30% duty cycle, out of total time period, only for 30% of the time we have on time, remaining time 70% we have off time. So the amount of delivered is only 30% of the total energy given to the motor. Same way for 70% duty cycle. So by varying the on time of a pulse, the amount of energy delivered to a DC motor is going to change. So thereby the speed of the DC motor can be varied. So the duty cycle is given by T on divided by total period. So total period is nothing but T on plus T off. So let us do a variation of speed of a DC motor by producing this PWM signal with different duty cycles. So thereby we can change the speed of your DC motor. So now let us look at a motor driver IC. So motor driver IC is required because the microcontroller, it can deliver, it can source or sink only 25 milliamperes of current. So if a motor works with high current ratings like 1 ampere or 2 ampere, then the current given by the microcontroller will not be sufficient to drive your motor. So in that case, we have to give an external supply, and this external supply should be routed to the motor depending upon the control signal from your microcontroller. So in that case, we make use of a motor driver IC. And also there is another advantage of using a motor driver IC. So if I want to change the direction of the motor, what we need to do, we have to physically remove the wires and interchange it with the battery polarities. That can be avoided. So for example, if I take a hedge bridge driver, so here you can see we have 4 switches and in between I have connected a motor. So for example, if all the 4 switches are open, then the motor is not going to rotate because the current is not going to flow from the supply to the motor. So that way the motor is not going to rotate. Whereas if I close switch 1 and switch 4, then what happens? The supply current, it goes through this path, it goes through switch 1 and it enters into the motor and it comes out of the other end and it goes to the ground. So thereby it forms a closed path. So now let us assume this flow of current induces a clockwise rotation in the motor. So in order to get an anti-clockwise rotation, we need to open circuit the switch 1 and switch 4, whereas switch 2 and switch 3 will be in short circuit. In that case, the current flows through the motor in an opposite direction. So thereby the rotation of the motor will be altered. So if I short circuit all the 4 switches, again the current will directly go to the ground, it will not pass through your motor. So thereby the motor will not be on state. So here we are not physically disconnecting the motor and changing the terminals connected to the polarity of your battery. So here just by configuring the switches, we are able to change the direction of rotation of the motor. So that is the another advantage of having your motor driver IC. And the third advantage is any rotating structure will produce a reverse voltage. Back EMF will be generated. So this back EMF, it should not go directly to your microcontroller. It might damage your microcontroller. So in order to have a physical isolation between your microcontroller and the motor circuit, we can make use of this motor driver IC. So one such motor driver which we are going to discuss is L293D motor driver. So it is a quadruple high current half H drivers. So this half H driver in the sense, it is mainly used for bidirectional flow of current to the motor, thereby the change in rotation, change in direction of rotation of the motor can be achieved. So it provides bidirectional drive currents up to 600 milliampere at voltages from 4.5 volt to 36 volt. So peak output current of 1.2 ampere is supported and all inputs are TTL compatible. So this motor driver can be used for driving the DC motors, stepper motors and latching relay drivers. So here I have shown the pin details of a L293D. So here the pin number 13 and pin number 12. So these two pins will come from your microcontroller. It goes to the in1 and in2 pins of your L293D. And the out signals, out1 and out2 goes to your motor. So depending upon the logic in this in1 and in2, so for example, if I give 1, 0, the motor will rotate in one direction. If I change it to 0, 1, it will rotate in opposite direction. So in order to enable this part, we have an enable signal which is at pin number 1. This is an enable signal and it needs to be connected to the supply. And there is a ground line which needs to be connected to 0 volt. And there is a pin number 8 is your supply voltage for your motor. So if my motor works with high current rating, then the supply required for that motor to run can be connected to this pin number 8. Same way I can connect another motor, second motor to the L293D. It can drive two motors. So here out in 4 and in 3 are pins from your microcontroller and out 3 and out 4 are connected to your motor. So depending upon the logic in this in 3 and in 4, the motor will start rotating in clockwise and anti-clockwise direction. And the enable signal for this side is pin number 9. So pin number 9 is an enable signal for the second motor and there is a BCC pin which is at pin number 16. So now let us look at on how to write a program to achieve a speed control of your DC motor connected to PIC16F877 microcontroller. For this, we make use of an integrated development environment which is Micro C Pro for PIC, where we will be writing our embedded C program, compile it, convert it into an hexadecimal file. Then we build our circuit in Proteus-8 professional environment and then import the text file onto the microcontroller. Then we try to check the logic. So this is the connection block diagram of your speed control of DC motor. So here I use a PIC16F877 microcontroller and I am going to connect a potentiometer. So by varying the potentiometer, the speed of the DC motor is going to get altered. By changing the potentiometer, the speed of your DC motor is going to get altered. So it is connected to the channel 0, AN0 of your PIC microcontroller. And I am going to use 3 port lines, RD0, RD1, RD2. So RD0 and RD1 goes to your in1 and in2 of your L293D motor driver. And RD2, I am going to use it as an enable line. So here in RD2, I am going to generate the PWM signal. So by generating this enable line is a PWM based. So whenever on time is there, at that time what happens, this logic in IN1 and IN2 will be used for the rotation of your motor. So by changing the on time of this enabled signal, I can change the speed of the DC motor. So for example, the wider the pulse, higher the speed. Lower the pulse, lower the speed. And the L293D motor driver is connected to DC motor and it is given with a supply of 4.5 volt to 36 volt. So this is the circuit block diagram for your speed control of DC motor. So now let us go and build the circuit in Proteus environment. So first let me create a new project. Select a location for saving our project. I have selected a location for our project, give a name for the project with an extension .pdsprj. Press next. I am going to select a default schematic. We are not going to create a PCB layout, so I am going to leave it as it is. We are not going to use a firmware. I am going to leave this as it is. Press next. So only schematic is selected. Press finish. So this is the location where we are going to build the circuit. In order to build the circuit, let us take all the components required for building the circuit. So I go to this PIC device, select the components. So I am going to use 16F877 microcontroller. So it gets listed here. Double click on it. It gets added to your list. Same way I require L293D motor driver. So L293D motor driver gets added to your list. Then I require a DC motor. Let me take a simple DC motor, add it to your list. Then I require a crystal, add it to the list. Capacitor, add it to the list. Switch, add it to the list. Resistor, then I also require a potentiometer. So I select a potentiometer, high granularity potentiometer. So these are some of the components which I require to build the circuit. So select all the components and then press OK. So now we have selected all the components. Now use this component to build the circuit. So first let me put the microcontroller into the schematic. Then I am going to connect the crystal. So I am going to rotate the crystal and place it onto the circuit. Connect the crystal to your microcontroller to pin number 13 and 14. Then I am going to connect the capacitors to the crystal to produce a stable clock frequency. So I am going to connect two capacitors of 33 picofarad to your crystal. So connect the ground. For getting a ground, go to terminals mode, select the ground, put it onto the circuit. Now let me change the values of the capacitor. Right click on the component, edit properties, 33 picofarad. Same way I change the value for the other component to 33 picofarad. Crystal I am going to use a 10 megahertz crystal. So change the value to 10 megahertz. Now I am going to, we are done with the oscillator circuit. Now we have to build the reset circuit. So for building the reset circuit, again I go to components mode, take the switch, place it onto the circuit, a resistor, connect these two ends. One end of the resistor I am going to connect a power supply. Another end I am going to connect a ground. And the intermediate point is connected to your memory clear pin. So by default, this pin memory clear bar will be at logic high. Whenever I close the switch, it goes to logic 0. So thereby reset operation takes place. So this is a reset circuit. So now I am going to build the motor side. So again go to components mode. So I am going to take the L293D motor driver, place it onto the circuit. So connect D0 to this in1, D1 to in2 and D2 to enable line. Right? So this D2 will be used to generate the PWM signal, thereby the speed of your DC motor will get altered. So the second part we are not going to use, so I am going to leave it as it is. Then we need to connect a supply to this VSS pin. Then Vs is a motor supply voltage. To give a motor supply voltage, let us assume we are connecting a 9 volt DC motor. So I go to generator mode. On the left side, you can find a generator mode. Select the generator mode, and I am going to use a DC generator. So click on this, add it to your circuit. Connect it to the Vs pin. So now I want to set the voltage for this generator. So go to edit properties. I specify 9 volt. I specify 9 volt. Then we can connect the DC motor to out1 and out2. So again go to components mode, select the motor, place it onto your circuit, connect the ends to out1 and out2. Then we have ground lines to be connected. So go to terminals mode, ground, place it onto the circuit, connect it to the ground terminal of your L293. So the second part we are not going to use, so I am going to leave it as it is. So here D0 is connected to in1, D1 is connected to in2. So here I give 0, 1 or 1, 0. So 1, 0 means it will rotate in one direction, 0, 1 means it will rotate in opposite direction. The speed control is achieved by producing a PWM signal in RD2. So and we have connected a supply to VSS pin and the motor supply to your pin number 8, VS pin. And the motor is connected to out1 and out2. So now let us connect the potentiometer, because by varying the potentiometer, depending upon the potentiometer value, the speed control is going to be achieved. So depending upon the variation in the potentiometer, the PWM signal on time is going to get varied, thereby the speed of the DC motor is going to vary. So I am going to connect a potentiometer to RA0 pin. So go to components mode, select the potentiometer, I will place it onto the circuit, connect this point to RA0. One end I am going to connect it to supply, another end I am going to connect it to ground. So we have connected the potentiometer to AN0 pin. So depending upon the value of the potentiometer, the speed of your DC motor will get added. So we have completed our circuit. Now let us go and do the programming part. Save the project. So let me go to Micro C Pro for PIC. Create a new project, a standard project. So here you select the location for your project. So I am going to put it onto this folder, Micro C. Give a name for the project. So speed control DC. Select the microcontroller which you are going to work on and select the oscillator frequency. So I am going to use 10 MHz as an oscillator frequency. Press next. We don't have a files right now. Press finish. So in this location we are going to put our code. So let me copy this code and put it onto the location. So here I have put the code. So first I have initialized a variable integer, unsigned integer, pot value. So here I am going to read the digital data from your A to D converter. So a pot value first initialized to 0, and I have initialized another variable t to be 1023. Then I have declared the functions. I have created two functions. One is software PWM and the delay function. Then in the main program, since we have connected a potentiometer to RA0 pin, this pin should be declared as an input pin. For declaring it as input pin, I specify it as 0x01. So which means this location, this pin which is RA0 is configured as an input pin. So by specifying 1, the pin will be configured as input. By specifying 0, the pin will be configured as output. So we have specified RA0 to be an input pin. Port D is connected to the motor, so I have configured it as output pins. So this is 0, 0, 0, 0, 0, 0, 0, 0. So all the port D pins are configured as output pins. Then in a while loop, I am going to use a library function ADC underscore read of 0, which means channel 0 will be read. So 8 channels are supported by your PIC microcontroller. We have connected the potentiometer to the channel 0. So I am going to read the potentiometer value in channel 0. It gets converted into a digital data, and the digital data, it comes into your pot underscore value. So now the potentiometer data is available in pot underscore value. I set the value for the motor, port D F0 equal to 1, port D F1 equal to 0. So F0 represents RD0 pin, F1 represents RD1 pin. So I set it in certain direction, 1, 0. Then I am going to use the function software underscore PWM. I send the value of this pot to this function. So if the potentiometer is maximum, in that case 1023 will be sent. If the potentiometer is minimum, then 0 will be sent. So by varying the value of the potentiometer, the corresponding value will be sent. Why it is varying between 0 to 1023? Because it is a 10-bit A to D converter. So 10-bit A to D converter, in the sense, the value will change from 0 to 1023. So depending upon the potentiometer content, I send that value to this function software underscore PWM. So it goes here, gets copied into duty. So here I am going to use this duty for varying the PWM signal on time. So I specify the enable line. So enable line is connected to your port D F2. So I set it to 1, then I create a delay with this time period. So this delay is nothing but another function here I have used. So I used a simple for loop, and in the for loop we are going to create a 1 microsecond delay. So for example, if my pot value is 1023, so 1023 will be sent here. So the for loop will run for 0 to 1023 of 1 microsecond delay. So which means we create 1023 microsecond delay, which is equivalent to 1 millisecond delay. So 1 millisecond delay will be created here if my pot value is 1023. Then in the next case, the off time, we set it to 0. We use T minus duty. So T minus duty is, if you see T, I have set it to 1023. So 1023 minus 1023, it will become 0. So the off time is 0. Right? So we give continuous signal. The on time is continuous. So thereby it is a 100% duty cycle is given to the motor. If I assume the potentiometer is half the value, so if it is half the value, then pot value will be 511. So that 511 is sent to here, and here it creates a 511 microsecond delay. So 511 microsecond delay will be used as an on time, and if I see the off time, again 1023 minus 511, it will be around 512. So almost same on time and off time. So 50% on time, 50% off time. So this is a 50% duty cycle will be generated. Same way, if the pot value is minimum, if the pot value is minimum, let us assume it is 0. In that case, what happens? Here it runs for only 1 microsecond. So my on time will be for only 1 microsecond, whereas the off time will be for 1022 microseconds. So thereby the motor has a very shorter pulse. So thereby it will not run significantly. So this is how we create a PWM signal, and this PWM signal is used to control the speed of your DC motor. So for running this program, we have to use the ADC library function. So I need to select the ADC library function from micro E libraries. We need to select the ADC library function. then we can compile this program. So in order to compile, I can go and build the project. So when we build the project, you can see it is compiled successfully. So now let us go and visualize the hexadecimal file created. So let us go and visualize the hexadecimal file created. So here you can find the hexadecimal file. So when I open this file, this is the hexadecimal file created from our Micro C Pro for PIC. So now let us go to the simulator part. In Proteus environment, let me put that hexadecimal file onto the microcontroller. Select the program file. Put that hexadecimal file onto the microcontroller. Then select the processor frequency to be 10 MHz. Press OK. So now we have put the hexadecimal file onto the microcontroller. So now let us see the working of the program. Press the play button. You can see the motor starts rotating. So if I change the potentiometer value, I am going to increase the potentiometer value. You can see the speed of the DC motor is increasing. Okay, now the speed DC motor rotates fastly. So when I reduce the potentiometer value, you can see the speed of the DC motor is reduced. So thereby we can increase or decrease the speed of your DC motor. So in this tutorial, I have discussed about on how to control the speed of a DC motor by producing a PWM signal. Thanks for watching. Please subscribe for more technical learning. Thank you.